everyone. Thank you for coming today. Today we will be watching a special seminar given by three speakers, Andrea, Wendy, and Karla, and I will now introduce them. So Andrea Hinojosa is a senior physics major at UTRGV. Previously, she has done research in the Department of Mathematics and holds an associate's degree in informatics. Her current area of research is in astronomy, with observational projects involving asteroid tracking and galaxy photometry, as well as work in data analysis. Wendy Mendoza is an undergraduate physics major at UTRGV and a research assistant at the Center for Gravitational Wave Astronomy. Her research focuses on the detection and tracking of asteroids at the Cristina Torres Memorial Observatory, as well as measuring the physical properties of asteroids using photometry. Karla Ramirez is a PhD student at UT San Antonio and UTRGV, and a graduate researcher at the Center for Gravitational Wave Astronomy. With a background in engineering physics, her doctoral research focuses on the alignment sensing and control subsystem for Advanced LIGO. Ladies and gentlemen, let's please welcome our speakers.
So on today's presentation, we're going to be talking a little bit about history, so a few women that made a big impact on science in the past. Also, we're going to be talking about a few of the cases that we have found in recent years about women in science, and also about a few statistics related to the women in different science fields. So I'm going to be talking a bit of history, like a few women that made a big impact on science. So I'm just going to be talking a very few women, or just a couple of them, that I found very interesting and I wanted to share with you. And also, just like a small comment, I really enjoyed doing this presentation because I found very interesting stories and biographies. So I hope that you also find it very interesting. I think I told this presentation like several times to my parents. So yeah, I love it. So the first scientist I wanted to talk about is Emmy Noether. So because this one was a scientist I met during my general relativity class. We were covering about Noether's theorem, so when trying to understand what was Noether's theorem, I started to read about it and tried to figure out what was the meaning of the theory. And I have the feeling, or I always have believed, that in order to understand something completely or well, you need to also kind of look about the background of that theory, like the persons involved and everything. So I have to confess that I thought that Noether was a guy. So the first, I just read the Noether theorem and I just assumed it was a guy. Like, you see that in Maxwell's equations is a guy, Newton's laws, Gauss's law. So it's always a male that is in the name of a theory or a law. So when I discovered that it was actually a female, I was like, wow, and I read everything about her on that time. So she was born in 1882. She was a German mathematician. So something interesting about her is that she came from a family of people that was very involved in science. So her father was also a mathematician. Her brother did a lot of discoveries on mathematics as well. Her older brother was also involved in chemistry. So it was a family that came from a very strong science background. So she had a lot of health issues when she was younger. And since her father kind of had something similar, he also had a lot of health issues. He kind of felt identified with her, like he reflected himself on her. So he kind of involved her a lot in mathematics because of that. So he explained to her a lot of mathematics, and he kind of encouraged it to her because of that. But it was because he kind of see himself on her. So in 1900s, she took a test in order to be able to be a linguistics or language teacher in a female school, and she actually passed the test. She did very well. She was very good at it. But she said at some point, when she finished the test, she said at some point, hey, you know what? I don't want to do that. I want to do something related to mathematics. So what she did is she started attending the University of Erlangen. So she was one of the only two females that attended that school from a population of 986. So there were only two females. And the other thing is that she was not allowed to enroll on that school because she was a female. So she was able to attend the classes with the professor's permission, only with the permission. She was only able to listen to the class, or allowed to listen to the class. She was not allowed to comment on the class. She was not going to be receiving any kind of credit. She was only allowed to observe. And she still did it because she wanted to learn about mathematics. So she had a graduation exam on like 1906, around that time. She took a graduation test or a graduation exam, and she did so well on the test that the person that graded the test was impressed. He said that it was one of the best tests he had ever graded, and they granted her the graduation. So she started working on the University of Erlangen and teaching mathematics without pay. So she was not getting any kind of reward on giving classes. She just did it because she loved doing it. And after some time, she went to the University of Göttingen because she wanted to also kind of pursue something higher in mathematics, and she started and in astronomy. So she started attending classes over there, and that's where she met one of the scientists that helped her the most in the rest of her career, and that was Hilbert. So just giving a little bit of background again. So Hilbert was a mathematician that was very, very interested in general relativity. People say that he was obsessed. He wanted to understand it, he wanted to do something related to it. And what he said is that physics had become so much more complicated for a physicist to do alone. So he said that mathematicians should get involved. So this is a phrase that I read that he mentioned, that is, physics is much too hard for physicists. So he said that mathematicians should be involved in it also. So he was, when looking at general relativity and trying to understand it and working on it, he found something that he could not understand at all. And that was that, you know that, for example, in electromagnetism, in classical mechanics, in any field, when a system loses energy, it starts losing also velocity, right? It's kind of a relation. You see something that starts losing energy, it starts deaccelerating. But what happens in general relativity is that when a system loses energy, it's not losing speed, it's actually accelerating. So he said like, hey, what is that? That cannot happen, right? So he started to try to figure it out and work it out. And what he did is that he called a mathematician he felt was one of the best mathematicians he met, and one that had a very similar mindset as him, and that was Emmy Noether. So he met Emmy Noether, as I mentioned, in Göttingen, in the University of Göttingen. So he called her back so that she could help him out. So in one time when he called Einstein to give a few lectures on the university related to gravitation, he also called Emmy Noether so that they can work that out together. So Emmy Noether started, when she went there, she started looking about general relativity, trying to figure out what was happening. And she found one of the theories that I consider one of my favorite theories because I really liked it, and it's the Noether's theorem. So what is Noether's theorem? Noether's theorem mentions that the invariance of a Lagrangian, so the invariance of a Lagrangian refers, you know that the Lagrangian is referring to the dynamics of a system, right? So the invariance of a Lagrangian, so it means that it's time invariant, or it can be, for example, coordinate invariant or velocity invariant. So it's like it's invariant on a change. So it means that there is a conservation law that is related to that invariance. So she found out that theory, and is considered one of the most crucial and important theories on modern physics. And she's actually called by a few people the person that changed the way or the path to physics, and she could not get a job. So why is that? Because she started, when she went to Göttingen, she got her theory, she found it, everything, she proved it, and she stayed there to give classes without payment as well, under the name of Hilbert, because she was not allowed to be a professor on the university. Hilbert tried to help her in becoming a professor. He made a lot of arguments. He tried to make her a professor to give the classes, or to have her name as a professor. And he was actually able to convince the science and math professors for her to become a professor, but he was never able to convince the humanity professors. So the historians or the linguistic professors, they never agreed for her to become a professor. So she stayed as a person that was not getting paid. She was only like, under the name of Hilbert, she gave the lessons or the lectures. So I can keep going talking about her like for the rest of the seminar because I know a lot about her, but let's keep moving. So the next person I want to talk about is Jocelyn Bell. So she was born in 1943, and she was helping she helped a lot on the construction of a radio telescope. So when she was getting data or analyzing data that she received from that telescope, she found a certain radio pulses that were on the data that she was analyzing. So she talked with her advisor. They started to work it out, tried to figure out what was happening, and she worked on it, tried to figure it out. And what happened is that she was discovering the pulsars. So the pulsars are neutron stars that are rapidly rotating. And on 1974, there was a Nobel Prize in Physics about the discovery of the pulsars, and it was given to her advisor, not to her. And it was mentioned that when the people asked her what she thought about it, she said like, well, maybe it was because of my status as a student, because at that time she was a student, not a professor. So she said that maybe it was because of that. The next scientist I'm going to be talking about is Vera Rubin. So Vera Rubin, since she was very young, she knew that she wanted to do something related to astronomy. She loved astronomy. She loved it so much that she constructed her first telescope when she was 10 years old with the help of her dad. So her dad was encouraging to her to do something related to astronomy as a hobby. When she mentioned that she wanted to study something related to astronomy, he kind of was dubious on her doing something like that or not. But he was encouraging more of as a hobby. But she still does something related to astronomy. So she graduated in 1948 as the only astronomy major in the university. And when she tried to pursue something in like higher education in astronomy, she was rejected. She submitted an application for Princeton and grad school, and she was rejected because Princeton did not allow women to take an astronomy class until 1975. So she was not allowed to take something related to astronomy in Princeton. So she was starting to do research, or she was the person that she started to do research related on galaxies. And a bit of background again. People at that time believed that galaxies, or the way of the distribution of galaxies, was kind of similar to the solar system. So you know that in the center of our solar system we have the highest, or the part that has the highest amount of mass, right? The sun. So the planets around it are rotating around the sun. And the inner planets rotate at a faster speed than the other planets, right? So people believed at that time that something similar happened with the galaxies, that the stars that were at the center of the galaxy rotated faster than the ones that were at the outskirts of the galaxy. So when she was doing observations with her colleagues and everything, she found out that actually the stars that were on the inner place of a galaxy were rotating at the same speed as the ones that were on the outskirts of the galaxy. So how is that possible, right? If we have the solar system as an example, why would that happen? So she found out that 90% of the mass of a galaxy, we cannot observe it. So what we can observe is only like a 10% of the mass of the galaxy. So she was the one that is the first discovery or the first observation of dark matter. So right now I have been talking about scientists that were on the 1900s, right? You were able to see that they were rejected from universities. They were not allowed to take classes, or maybe that they were kind of like left out from the groups. They were not paying attention. When they tried to say something, people kind of didn't take them seriously, right? So that was in the 1900s. So I included her in this presentation because imagine how things should have been for her in the 1700s, right? 200 years before that. So she's María Gaetana Agnesi. She was a mathematician, and she's considered to be the first female mathematician considered important or the first female mathematician to be important in the field of mathematics. So she was something interesting is at that time females that kind of were interested in science were left out completely from groups. So people didn't want to marry them. They were kind of like humiliated at that time. They were ignored, or they were very, very treated badly, right? But something interesting about her is that her father was actually very proud of her. So she came from a very rich family. So her father was very proud of her, and he loved for her to display her knowledge. So whenever he had a meeting, he would ask his daughter to come with him so that she could display her knowledge to the males. So, and she loved doing that, like basically displaying that she was smart. So she liked doing that. So she did a book that is called, or is translated because she's Italian. I forgot to mention that she's Italian. So the translation of her book is Analytical Institutions for the Use of Italian Job, and it was considered to be the most complete book from that century, and it was used for teaching mathematics for like 50 years in Europe. So it was a very important book. And in that book, she did a lot of work on something that she called the curve of Agnesi. So that curve is like a cubic plane curve that was very important. She did a lot of research on that curve. She worked with it for years, and when she did the publication, she called it the curve of Agnesi. But as I mentioned before, people at that time were very against for women to do something related to science, right? Very, very against. So when she sent her book for publication, people were kind of laughing at her, like laughing at the book because it was like writing by a female. So they changed the word curve, because in Italian the word curve and witch is very similar. So they changed the word curve and called it the Witch of Agnesi. So that name stays until today. That curve is called the Witch of Agnesi, but it was actually like a misnaming by the people who print the book. So she was laughed at because of that name, because she was started to be called the Witch of Agnesi. She was considered a witch, like they called her names and everything. But still, her book was so impressive that even the Pope was amazed by her work. So he appointed her as a mathematician professor in the University of Bologna in the 1750s. The only thing is that by that time, she became very, very religious, because her father died. She started to feel kind of uncomfortable with what she was doing. So she decided to completely leave everything out and just focus on religion and helping poor people. So she rejected the position. She stayed in the poor houses helping people, and she died there after some time. She stopped doing things on mathematics. Now, the last scientist I'm going to be talking about is Rosalind Franklin. So she was born in the 1920s, and by the age of 15, she knew that she wanted to do something related to science. The only thing is that you can see with María Agnesi, for example, her father was supportive, or with previous parents, they were kind of dubious, but it's okay, you can do it. But in the case of her parents, they were completely against for her to do something related to science. They were against it. But she still did it, right? So she graduated, she got a scholarship for doing graduate school on a university, and she decided to start graduate school. The only thing is that her supervisor or her advisor was so unsupportive of her that he believed that he knew that she had the abilities to stay there as a graduate student, that she had the abilities to work on the research, that she was smart. He knew it, but he was against of letting women do something related to science. He was thinking that men were superior than females. So he put a lot of struggles for her on her studies and her research. And it was so much that struggles that he put that the first job offer that she received, that it was doing research on coal, she took it and left graduate school. So she started doing research on coal. And she did it for a few years, and it is said that she actually enjoyed it a lot because she had to do the research independently. So it was just her doing the research. And she liked it because, imagine, if she had a very supportive advisor, people didn't believe what she was saying, she was not paying attention. So if she had to do things by herself, it means that she didn't have to convince people that she was saying something correctly, right? So she enjoyed that time a lot. After some time, she got another scholarship to start graduate school at King's College. And she decided to take the opportunity and started doing research on X-ray crystallography. So at that time on King's College, Maurice Wilkins was also doing research related to crystallography and also the DNA structure. And he was on a vacation when she was asked to come and start doing her research. So when he came back and he saw her, he thought that she was his assistant and started treating her as an assistant, like as if she was in an inferior level. When he was told that she was actually his colleague, he kind of still treated her the same, as an assistant. So people say that they had a lot of clashes between them because of the mistreatment that he had for her. Like, he didn't treat her as an equal, or she didn't consider her research that much. But she still started doing research there. she actually was the one, when she was there, she found, or was the person that found the structure of the DNA. She found proof about that the structure of the DNA is a helix. She found the proof. And since she did a lot of research regarding to the DNA structure, and she found the proof, she started to give lectures on the university regarding the findings that she did. And on one of her lectures, Watson attended the lectures. So, giving a background, Watson and his colleague Crick were doing at that time also research on the DNA structure on the DNA structure. So when he attended the lecture that he was giving, he was impressed because she found something to prove that the structure of the DNA was a helix, and he was not able, like him and his colleague were not able to find it, right? So he came back and explained it to his colleague Crick, the findings that she did on the DNA structure. And people say that when he tried to explain to his colleague what she was talking about, he was not able to do it because she explained it, or it was so complex for him, or so involved that he was not able to explain it to another person. So he did not completely understand what was happening in her lecture. But after that, Watson and Crick went and tried, because they were interested on the data that she got and everything, and went to her college to ask, not her, but her colleague Wilkins, to show them the research data that she had gotten. And Wilkins, without letting her know, showed them the research that she was doing, the data that she got. So it was done without her permission and without her knowing. So he showed them the data that she had collected. And after a few years, there were the publications for the findings, right? And Watson and Crick, they didn't have the proof, they didn't got the data. They published the DNA structure, like their findings, right? And that was done before she had the time to publish her paper. So when they published their paper, it was considered that their discovery was groundbreaking, that what they did was amazing and everything. And by the time that she published her paper, since it was after them, it was considered only a paper that was a supportive paper for their paper. So she was considered to be like just supporting their findings. So she, after a few months, she left the university, she left King's College, and started doing research on another things. She started working on science, on other fields. And in 1958, she died because of cancer. So by 1962, Watson, Crick, and Wilkins got the Nobel Prize for the discoveries of the DNA structure, and she was not included on the Nobel Prize because she died a few years before. And remember I mentioned that she was doing X-ray crystallography research before? So in 1982, her other colleague that was doing research with her got the Nobel Prize on Chemistry for that research. So it is considered that if she had been alive on 1962 and 1982, she would have been a person or a woman that have gotten 2 Nobel Prizes. And this presentation, basically, what I have been talking right now is you were able to see like all the hardships that different females had in the past in order to follow something related to science, right? To do something related to science. They were not paid attention. They were not allowed to enroll to classes. They were not allowed to enter universities because they were females, right? So you were able to see all the struggles that they had. And they still, their passion was so strong on science that they still decided to do it, right? So right now, we have them as our role models. So we have them as kind of like inspire us, or inspire the females on our generation to do something that is related to science, right? We have them as an inspiration. So I will let my colleague Wendy to.
Hello. As you guys can see, what this greatest scientist experience was gender discrimination, which is still happening today on the STEM field. So there's 50% of gender discrimination and 50% of sexual harassment on women. Only 40% was able to succeed, fully succeed, the women field, and 66% of women were left out in important events. So I actually discovered this research. It's the Pew Research Center conducted survey, and it's a survey that it was conducted in July through August 10 on last year, 2017, by 4,900 people, 914 people. So the blue represents the men and the purple represents the women. So only 90% of men experience discrimination at work and 50% women, which is really high. Earn less than a woman doing the same job, it's 6% and 29% of women. And were treated as they were not competent, it's 4% and 29%. And experience repeated small slight at work, only 4% men experience that and 20% of women experience that more. And I don't want to go that into detail, but the last one, being denied a promotion. Only 4% of men were denied and 6% of women. So that's still a lot. And I want to talk a little bit more about cases, what other scientists have been saying in the video. So Tim Hunt actually won a Nobel Prize in 2011, I believe. I know he's a biologist. I don't know the Nobel Prize because I didn't really care what he was until I read what he said. So he was interviewed at the World Conference of Science Journalism on June 18 by a journalist, South Korean journalist at the St. Louis University. And basically, this is what he said. Let me tell you about my trouble with girls. 3 things happen when they are in the lab. You will fall in love with them, they will fall in love with you, and you will criticize them, they will cry. So he later, a couple of days has passed, it was like a big controversy on Twitter, everybody was getting mad. He did apologize, explaining the situation, like, yeah, I mean, I said that, it was a joke, but I'm sorry. But later, well, it's kind of true. So it wasn't like a proper apology, what I heard of. It's ridiculous what he said. And then the other one was the Teller lecture suspended by CNR. This actually happened this month on October the 2nd. So he made a presentation of saying physics was invented and built by men, explaining how women are more promoted on jobs. We get more on scholarships, things like that we don't really get that often. So it was a big controversy as well. He got actually suspended by the World Leading Nuclear Research Center, and it's the controversy is still on Twitter. That is going to you guys want to see. So I found this article. It's called "The Stories of Sexism in Science." Sorry about all the women in this laboratory. So if you guys are interested in this article, there are different stories of different students on different universities. These stories are anonymously, so you won't be able to see like the name who wrote it, but you will be able to see the different universities who experienced that. One of the I got so impressed was, I need a younger postdoc than you. So that was actually written by the University of Oxford, and this lady is trying to get her PhD. So she was talking to her mentor, and the mentor was like, I can't have you because you're getting old. I need a younger PhD student. You're getting old, you're a mother, you don't have time to be with us. And then the other that I found it really ridiculous was, women are simply worse in science. It was actually written by a undergrad student, a chemist from the University of, I think, London. She mentioned that she met a PhD student they're working in the lab, and then the PhD student was like, I think women are really worst in labs. They are useless, and they should not be here in this lab. So she didn't complain, but she would try to process what happened in a funny way. And there are more stories behind it, but I don't want to really explain too much because they're more sexual harassment stories, and I don't want to explain the stories because it's not appropriate to say it for me. But if you guys are interested, check it out. It's a really, really good website. Now I will leave it to Karla. Go ahead.
Hi everyone. So far we have here amazing women in history that have done groundbreaking discoveries. You have here like different gender situations that women have found just for being women, for example. But after all that, where are we now? Okay, so in overall, women account for the minority of world's researchers. So according to the UNESCO Statistics Institute, only 1 in every 3 researchers is a woman. This means around only 28% of the researchers in the whole world I'm woman. Yeah. So this number has a lower representation the higher degree you go. Until high school, this average is 50 and 50. And after that, around 30, only 32% of the undergrads are women. So this is a strong relation. On the higher the diploma, the lower this number is for women represented in science. But the most striking is that if we talk about scientific awards, only 3% of these awards, for example, on the Nobel Prize, are won by women. So instead of these numbers getting higher, these numbers are still low compared to another fields different to science. Let me show you this map shows how the percentage of women researchers by different regions, from 47 in Central and Eastern Europe to 44% in Latin America. That is almost a 50% in comparison to men researchers. I think for me was like kind of hard to believe that in North America or in the United States, where women receive a lot of they have a lot of resources to get into science fields, this number is around 30%. These numbers are still low if you see in Africa and Arab states, Southwest Asia, that is less than 20%. So why these numbers are so low? Let's focus now on how the women are represented in physics. I will show you a few statistics about this. If you have any questions, let me know. So this graph shows the fraction of just U.S. Women, including citizens and temporary residents in the United States, just United States. These statistics are from the American Physical Society. And in the science fields, from biological sciences, chemistry, math, astronomy, engineering, physics, and also computer science, these numbers are very different. Women has a higher percentage representation in biology, but if you go to physicists, the gender gap is still high. If you compare like around 20% from bachelor's, master's, and PhD degree to 60% on average on biological sciences. So it is kind of thinking why these numbers is still so low. Women, let me mention something before I continue. I was reading and since 1991, around 600,000 papers in science, including physics, have been published. From those, 600,000. Only 45% have as an author a woman. But in the last few years, 13% in physics papers published, a woman is mentioned as a last author. It has a rate of 0.1% of a growing rate. A growing rate of 0.1%. This means that it will take around 258 years to reach a 50% of papers published by women and men. Imagine 258. So this, let me show you a graph comparing a bachelor's degree and a higher degree as the PhD. Until 2002, both a bachelor's degree and a PhD were growing. We're almost reaching 20% for PhD and passing the 20% of women in a bachelor's. But after that, bachelors start decreasing, and these numbers is still decreasing in bachelors. PhD is still getting around like 20%. So why women are more likely to live than stay in science or in physics field? So imagine if this number is low for getting a higher degree. For after getting a degree, if you see like women getting a faculty position, this number is still low. You will find around 11% of positions in universities are filled by women. If we go from instructor, adjunct professor to full professor being the highest rank, this number is less than 20%. For a full professor from 2002 to 2014, this number has doubled from 5% to 10%. And it's the same for associate professor from 11% to 80%. So around it has grown 5% in the last 15 years. And it's the same for the degrees earned by a woman. It has from 10% to 16%. It has grown like 6%. So why women? Why these numbers are low? So what are some of the reasons that women don't keep their track into science fields like physics? If I tell you thinking a physicist, who would you think first? Yeah, you won't think in a woman as a physicist or as a scientist. This is the most likely you will find if you go to Google and put physicist. If you put scientist, it will be the same. Just this is not a physicist. It's a woman in chemistry, right? So why we have this thinking? Because women are not enrolled, are more likely not to enroll in science. It is being said that our women are less likely to enter and more likely to leave once they start in science education. There are different reasons. If you interview, 10 women from being a bachelor, an undergrad to a postdoc or a researcher in a higher job, they will tell you different reasons for which they stay or they will leave their job or their position or their studies. Some of them are the work experiences, isolation. Sometimes women decide to be isolated for work partners because they want to avoid some situations as sexual harassment, for example. Some work environments dominated by male and this is very present in scientific uh, fields. Feedback. Sometimes or women get a lower feedback than co-workers, for example, just because they are women. So this is gender bias. Lack of effective sponsors. Sometimes sponsors or supervisors or professors don't want to work with women because women get pregnant, women get a family. They think because they are women, they will leave research, they will leave what they have, they work. So they will find different priorities, while a woman can have two priorities, that is their career and their family, for example. This is good to mention that lower pay rates compared to men with the same duties. On average, women get 80% of a pay rate compared to what a man gets. Even they do the same, they have the same job, they have the same skills. So these are the most common factors that push women to leave the science field. But you will find, this is just to mention some, they will find different reasons why women leave. So now, mirando al futuro, looking into the future. I had the opportunity to work, to do research in the LIGO Livingston Observatory on Louisiana. Let me introduce you 4 amazing women that work in these observatories. Her name is Keiko Kokeyama. She now is working on Kagra in Japan. Her name is Sheila Juyer. She got a scientist position in Hanford, in LIGO Hanford. The woman in the back, her name is Ana María Effler. She has been working in LIGO Livingston Observatory since almost the beginning of the building of the intercontinental. Her name is Lisa Barsotti. She has done amazing contributions to LIGO, from the alignment sensing control subsystem to the squeezing. They are working right now for the following observations. These are 4 women that have worked hard to reach their place they have now. Let me just mention that out there are so many resources that can help women to keep their track inside. This is just to mention one. If you go to Google, for example, and you look women in physics, scholarship, whatever, you will find the American Physical Society site, and there's a link that has a lot of resources, from conference for women to seminars, to such as work environment skills seminar, to scholarships and awards that women can apply to keep studying or pursuing a degree in physics, for example. Let me finish just with this. So when you want something, all the universe conspires in helping you to achieve it. Paulo Coelho. I think this phrase is good because there are so many things out there for women, for men, for anyone to keep pursuing what they want. Thank you.
Great. So I think before we do questions, our speakers wanted to have an opportunity to talk a little bit further about more personal experiences. So I think we're ahead of time still because we started late. So we have some time to do that, and then afterwards we'll take some questions. So.
Okay. Well, my experience of gender discrimination was actually with my dad. This happened during high school because I was gonna already finally graduate. It took me a while to graduate high school. He wanted me to pursue beauty school. I don't even brush my hair or paint my nails. So, and my brother was telling him to pursue computer science or any science-related field. So, as me being a woman, he thought that I was stupid. Okay, this girl, I don't think he's gonna make it. She's really stupid. She's a woman. And I'm gonna be honest, I'm not really smart, but I mean, I consider myself. Okay, it's not true. I accomplished some things which I'm proud of myself. But I was still able to do it. I didn't really care about my parents. And now I'm here with you guys doing research, and I'm honored to do asteroids as well. And I'm also getting scholarship at the STEM field. If you guys are interested in scholarship, let me know. And getting grants as well. And I'm traveling with you guys as well. So I'm really proud of myself. And they don't really know about it because I don't really live with my parents. But I haven't mentioned them about that. So yeah, that was my experience. Gender discrimination.
So in my case, most of my experience don't come from my family because my family is very supportive on both genders. So you can see it as with my twin brother and me. So we were raised basically with the same opportunities, with the same, basically with the same opportunities, like the same way, right? So you can see that even now we treat each other equally, completely. We have both of us have different goals, but we are planning on pursuing them, right? But I have had a lot of different situations, like with students or with classmates. Mostly, I have been a tutor for like 3 years now, right? So I have had a lot of situations with students, and in this case, that happened like one year ago, last year in the summer, and that has been happening like several times, right? And especially with engineering students, like I always have trouble when teaching something to engineering students. So in this case, yeah, it's bad completely. So okay, so this was in the summer. I was the only physics tutor on the learning center. So I just to give like a bit of a story on that. I was awarded several times like the recognition of being the best tutor of the year on the science and physics classes because I have confidence on my abilities of explaining physics, right? So I remember that 2 students from engineering came to me, or not to me, came to the learning center to request a physics tutor. So they sat down on the table, I approached them and asked them what they needed help with. And they looked at me and they were like, oh, no, I don't think you can help me with this. And I was like, oh, but what are you coming? No, you cannot do this. And I was like, looking at the computer, I saw it was physics 1. And I was like, oh, no, of course I can help you with that. I'm the tutor. I can help you with that. It's physics. I can do it completely. And they looked at me, and I remember they laughed like as if I said like the funniest joke ever. So in Spanish you say a carcajadas, right? Like literally. So they laughed at me like for a long time. And then I remember that I just stood there, right? And basically I used to see this. I decided to just say, okay, it's okay, right? I sat down, like in front of them, and they were waiting for the next physics tutor, right? But I was the only one, so they basically didn't receive help there, right? So they just after like an hour, basically, they stood up and walked away. So that was my like worst experience, right?
My experience, well, I have heard a lot because my bachelor's was in engineering, and as you will think, yeah, I found, or I remember just like two classmates, being women. But before I got into my master's degree, I got pregnant. I have a young lady. She's almost 9 years old. She's amazing. And when I started my master's degree, I started working with some professor in the university. And this professor at some point told me, "Oh, I believe you should change to something easier because you are mom, and I don't think you will have like enough time to do this. So why don't you do something easier than, for example, being a teacher?" He was telling me this like so many times for a long, long time that at some point I believe it. I say, okay, yeah, it's true. Like, I am a mom. I need to like have time for my daughter, for my family, and everything. And I was about to go to the School of Education to ask for get a certificate as a teacher in physics, right? Because my background was in physics, engineering, mathematics, and everything. But I don't know, for something like all the planets align, and I found someone who told me, no, why you are gonna change to be a teacher? That you are half the way and you can do it. And I won't mention names, but I am so thankful I found this professor that told me that I can and I should keep doing this and being in science. So don't believe people if they tell you you are not good enough or you are not able to. Just prove yourselves you can do whatever you want. Thank you so much. Do you have any questions?
I have a question regarding your part of the presentation. All this information you have, is it from STEM fields only, or does it include psychology, English?
No, this just is like a STEM field, like as I mentioned, like biology, chemistry,
So the
mathematics.
inequality is still big in STEM, probably not in like as compared to other.
No, for example, like, yeah, you're right. Sorry, you're right. If you, like, women have won, for example, like the Nobel Prize, but there are more women that have won the prize for, like, humanities rather than science. So in science, just 3%. So, yeah, there's a big difference in, like, I don't know, humanities science, humanity
I
field.
think only literature and social science like economy.
Uh-huh.
You got the Nobel Prize. Yeah.
Yeah, so it's kind of like big difference in numbers. But yeah. Any other question, like comment, experience do you want to share?
I have another one.
Yeah.
About the 11% of the women that get professorship, is that the 11% of the 30%, or is that 11% total, like 1/3 of this? Because I don't know if what the proportion of women that get scholarships. There are 30% of women that goes to PhD.
No, that's 28% of women are researchers. Like a postdoc, have a research position in science.
And from that population, 11% get professorship, or is it from the Total population.
And the
of
total population of women, like 11% get a like.
professorship.
No,
Okay.
I'm sorry, I'm confusing now.
Mm.
From the positions filled as a faculty member, those
Ah,
of that
so from that,
100%, just
Out of
11%
100 full professor, 11 are women.
are women. Yeah.
Okay.
So there are different percents for like different numbers for different situations.
And I think if you look in our department that we have 40 faculty members, only one female has a full professorship. And there are probably like 10 of us that are full professors.
If you want more information about it, you can go to the APS site and go to statistics, and you can do research even by university or like UTRGV is not there, but if you go to like Panam, you can see like the percentage of women in like faculty positions, and then how many women have graduated from like science field, how many are like from physics, how many are got a bachelor's, how many had a master's, and like it's striking. Like these numbers are pretty low.
Also, I want to say we don't want to shame men, because I know there's great undergrads, grad students, PhD students, men who are supportive as well with women. But there are also women against other women in the science field. So just let you know, it had happened with me personally with academic advisors. They're like, are you sure you want to do physics? You don't want to do teaching or psychology? I'm like, no, I want to do physics. As much as I went a couple of times. So it does happen with women.
And there was a woman too.
Yeah, and there was a woman.
Not encouraging you
Yeah.
to pursue this.
Yeah, so like the main point of the main goal of this is more it was like show you like how where women are now, on what is the struggle we have gone through. Yeah, it's not like to shame or to victimize, just to show you the situations like we go through, like in or career studies, whatever.
And I think an important point to take is why are we having seminars about this? Because I think we need to create some awareness among us, men. That it's also up to us to change the culture and the way society perceives role models. And I think it's important we are.
Just a comment, so along those lines, while I have been aware that these are big issues, I wanted to thank you because it provides some context and enlightens some of us that are aware of the problem but aren't really aware like how pervasive it is and how deep of an issue it is. So, thank you.
Any other questions or comments from anybody? Okay, well, let's thank our speakers once again.